Good afternoon, ladies and gentlemen. We are Crayon3D team. I'm Miles, I'm a producer of this team.
I'm Lei, I'm an artist.
I'm Faye, I'm a programmer.
I'm Ben, I'm a programmer.
And I'm Sharky, I'm also a programmer.
And our advisors are Mike Cristo and Oscar Castillo Panera. Crayon3D is a student pitch project which aims to become a platform for the building virtual world class in 2009. The original idea came from the children's book Hello and the Purple Crayon. We want students to use this platform to create a lot of interesting and impressive games. Also, we want them to focus on the game mechanics instead of the game technology, so we provide good documentations to save their time. Crayon3D is an easy-to-use platform built with Panda 3D. This platform provides 4 different features. Fish Tank VR provides a uniquely immersive 3D virtual space. Finger tracking allows the fingers to be used as an input device. Gesture recognition allows a new way to analyze user drawing and convert them to data that can drive a game forward. Physics engine allows the 3D object interact with each other and their environment. Our well-documented API and demos will help students to create imaginative games and fanciful worlds in a new way. We did a lot of research, such as the Wii New device, Wii Motion Plus, methods for hand tracking, finger tracking. You can easily find those informations on our Google site. As I mentioned earlier, Crayon3D is an easy-to-use platform which integrates 4 different features. We were not only building small game demos, but also developing the software and hardware. Here are our 3 deliverables. First, software development kit allows the software engineer to create applications for a certain software package. We also provide API reference, tutorial, manual, tutorial, and demos to help programmers to understand our code easily. Hardware devices are very important for our project. We have created a hand tracking device and a glove. Both devices are easy to make. You can create a new one in a short time. Of course, their materials are very cheap. It only costs $40 to create a glove and glasses. In addition, we will finish 4 more gloves and glasses before this Friday. Now, Lin will talk about our metrics of success.
Thank you, Malers. First, we have implemented the following features. Fish Tank VR, which allows users to have immersive experience in 3D virtual space. With gesture recognition, game designers can make cool game mechanics. Fixing engine that will eye tracking provides a different way of using Wii, and it also broadens the way of tracking. We can track anything that emits infrared lights. Physics engine that makes the game more real. Python interface to Wii use. Wii use is a library provided by the Wii use community. It will make it easy for programmers to get data from Wii. And we will provide future BBW students with a manual in PPT format. API reference that programmers can code easily. Sample code that demonstrates a sample row. Second, since our paper is accepted by GES, Crayon3D platform will be presented in GES on June 17th. Last, we have shared our library with Wii use and Panda community. In addition, Root is considering to use Crayon3D platform as one of the platforms in National High School Game Academy this summer. Here's our schedule. Before HAP, we focus on implementing our features by working on software development in parallel. After HAP, as a feedback we got, we need to make fun demos, so we focus on making game demos and wrap up. In addition, there's always a concern that our hardware devices looks fragile, so we also work on improving it. After soft opening, we've been working on polishing our platform and making our hardware devices look more durable. And Sharky will talk about our hardware devices.
Thank you, Lin. So one of the major problems that was noted during our soft opening was that our hardware devices looked fragile. Actually, it's easier to show than explain. So these are the hardware devices that we created during the semester. Some of them worked, some of them didn't, but all of them, they look awful. So what we did during after soft opening is work on the hardware devices. And this is the result of all of our efforts. Look at that. That's cool looking gloves, right? So it's a culmination of our skills in circuit design, soldering, and sewing. And it actually works. Also, we were able to fix our infrared glasses. So instead of putting on cap with a Wii sensor bar and the potato chip flip, we're actually using this one. So we also had we put a lot of effort in designing our software. So this is the software design that we created, and this focuses on expandability, flexibility, and usability. It's expandable because it's designed in such a way that new features can be added easily by future programmers or other developers. It's flexible and it's usable because of the different layers of abstraction that we created. So for example, for programmers who want to deal with low-level details of using a Wiimote, they can use this part. For programmers who doesn't want to deal with those details and just wants to use the Wiimote, they can use this part. We also provide several helpers for specific applications, such as using the infrared tracking as a cursor for like a mouse, gesture recognition for analyzing user drawings and converting them to usable data, and an interface for using fish tank VR, wherein we liken the TV set to a fish tank, and if you move around, you see different parts of the fish tank. We provide the physics interface separately because we don't want to force programmers to always use the Wiimote as an input device. So they can use our physics interface using other kinds of input devices. So we've been harping about how easy our platform is, and I guess the only way to show it is to create a game in less than 5 minutes live. Actually, less than 3 minutes because I've been talking too much. So this is a simple game. It loads an environment and a box. Very boring because nothing's happening. So let's add physics because physics is awesome. So what we need to do is we just need to add this line to add the library, create a Crayon3D scene, create a node, and finally start physics. So let's see. So that's just like 7 lines. And the result would be this. So you see the box fell down, it bounced around. Pretty awesome. So now we want to add more interactivity. So we want to add cursor using the Wiimote. So what we need to do is we need to add the library, Wiimote handler, create the Wiimote handler object here, and then create a cursor class, and that's it. So that's actually around, again, 7 lines. And this is the result. And then, look at that! 7 lines. Pretty awesome. So now we want to add another interaction. So we want to add gesture recognition. So we want to add more boxes by using gesture. So we need to add this library, and we need to create a gesture handler object, several event handlers. The details, don't worry about them because we have a manual. And you're going to understand them if you read the manual, if you're a programmer. So that's approximately 20 lines, and this is what we get. So Ben, can you draw a box? Okay. Oh, look at that. That's pretty amazing. So that was 40 lines, and how many features did we add? We added a lot. So I turn you back to Ben, who's going to be continuing our presentation.
Thank you, Sharky. So we made several changes to our project due to several reasons, such as technology constraints, playtest results, and of course, opinions from ETC guests, students, and faculties. For instance, we adopted an ETCer's opinions and added the feature sculpting and coloring to our platform. It allows the developers to create a modeling application and extends the capability of our platform. Secondly, we have improved our previous composite gesture recognition to a continuous gesture recognition as a result of our playtests. According to the feedback we got from those naive guests and professional game developers, we realized that it will be more intuitive and